Okay, cool. So this is Delivering Services at DigitalOcean. I'm Mac Browning. I am a software engineer on the delivery engineering team. And so you might start out by asking a question. So this is Sammy, by the way, in case anyone's not familiar with DigitalOcean. Sammy, our beloved shark. So delivery engineering. Delivery engineering enables continuous delivery for teams at DigitalOcean. We like to think of ourselves as building blocks for other teams in terms of like a platform to deploy your software on, tools to monitor and alert on your given metrics, and overall simplifying that kind of step from the development lifecycle to production lifecycle. It's a pretty big leap sometimes, and so we want to really narrow that, make it easier. So like every good story, ours has a villain, and so Chef is the villain. In case anyone's not familiar with Chef, it's a configuration management tool. We have written Chef since the beginnings of DigitalOcean. It's still very popular, but it's kind of shown its age since it's been with the company since it started out. You can really think of it as like that monolithic code base at this point. And so a little bit about the history. So I call the time before delivery the Dark Ages. So at the Dark Ages, Chef was probably 95% case. There's a little bit of Ansible, Capistrano, Bash, whatever, but mostly Chef. Every team needed to know how to write Chef in order to deploy your code. And so this is a huge cost in case anyone hasn't worked with a Chef code base. It's very specific to the company, which means there's a lot of tribal knowledge. And it's also kind of really tough to onboard onto. And it's also really high risk in terms of like you make the wrong change, it's touching every machine, and now things have broken in ways you had no idea to expect. So ultimately, this meant new deploys could take days, maybe even weeks, depending on the familiarity of the team and the group with Chef. And that's just a huge cost of doing business for a startup like DigitalOcean. And even then, updates at that point could be on the order of hours or days, depending on the risk of the update. So, given kind of where we were, where do we want to go? And so ideally, we want to go somewhere where engineers can deploy early and often. Essentially, as soon as you start writing your application, you can deploy your application to staging, development, production within minutes. And then from then on, it's the same process of deploy as often as you want. It shouldn't be any more expensive to deploy your application the first time than it is to deploy it the 100th time. There should be no need for tribal knowledge. So a big thing about Chef is that tribal knowledge made it really tough to onboard. And so no need for tribal knowledge would be kind of top tier. And then at that, all the tooling should really encourage best practices. We've really grown and learned a lot about running software and managing its lifecycle after you kind of ship it. And so we really want to make sure all new engineers or all current engineers continue to follow those best practices that we invested a lot in discovering. So what do we need to get there? Obviously, since we're DigitalOcean, it must be nautical themed. It's like top tier. Has to use Docker. It makes really good conference talks. Lots of GitHub stars are really important for any piece of software, as we all know. And it has to be web scale. But in reality, what do we actually need? So big things for us were an active community. We knew that it was just going to be a really important part of our infrastructure. So the more people involved in that, the easier it would be for us to adopt it. Had to be production ready. Like we're not really investing in this to write our own thing. We're not really investing in this to do discovery. Like we want to make active change in our company. And so in that case, it needs to be ready for prime time. Or at the very least, we need to be confident enough that we're willing to put it into production. And then also has to be batteries included. Like I said, we don't want to build our own thing, or at least we don't want to build steps 1, 2, and 3. We want to focus on building steps like 8, 9, and 10. And so that's something that was really important, was kind of that batteries included flow. So obviously we're here at KubeCon, so Kubernetes was one of the obvious choices. We actually spent a lot of time looking at other things, and ultimately kind of just settled on this because it gave us checked all those boxes, and was pretty enjoyable to start with. However, a little different than what a lot of companies have done, at least from a lot of the talks I've seen, is we didn't adopt it such that everyone's writing YAML files and using kubectl create. We actually have our own abstraction on top of Kubernetes. And so we call this DOCC. DOCC's a tool for deploying containerized stateless applications. DOCC actually used to mean something. At this point, it's now just a happy accident that sounds like doc, like boat docks. So I'm just going to go with that. So DOCC essentially replaces kubectl for our developers. The only engineers at DO that have access to kubectl are team members of my team, essentially for administering the cluster, administering cluster add-ons, doing the normal day-to-day of like managing a cluster and spinning up new nodes, etc. Are the other engineers that are throughout the company do not use kubectl. They are not off. They don't have creds for it either, but they do use doc. So doc looks a lot like kubectl when you take a look at the CLI. There's a CLI component which is also called doc. The docs aren't great for it. We actually have another Google Doc that we use for the docs, so the docs aren't excellent. But this gives you an idea. Like, it has a lot of the same things you would expect to see in kubectl. There's deploy instead of create, a bunch of inspect, list, etc. And so maybe we'll get into a little bit of those. But really, I'd like to highlight another component of doc that I'll get into in a second. So you can think of doc as kind of a curated subset of the Kubernetes ecosystem. This is the scalpel, not the Swiss Army knife. Kubernetes gives you all of the features in the world. It also gives you all of the configurables for all the features in the world, which make it a little unwieldy at times. We target only stateless services. This means there's no support for pet sets in doc or anything along those lines. We actually don't even expose mounts to users, and so we really picked a very curated subset. And I'll get into a little bit more why later on. And then your declarative deploys. So it's push forward the same thing that Kubernetes pushes forward. It's really important that each deploy is pretty immutable, and you know what you're getting when you go into it. And so we wanted to maintain that behavior going forward. So doc uses a manifest, similar to the YAML for Kubernetes resources. It's just a lot smaller. It describes your application, all the components that make it up, name, maintainer, etc. It includes add-ons, things that don't normally ship with Kubernetes, so like support for the way we collect metrics at DigitalOcean, alerting. You can write alerts right alongside your deploy, and then ingresses. So we run doc and our Kubernetes clusters on our cloud, which is not a currently supported Kubernetes cloud. So it is a public cloud, but we don't have support for like the cloud load balancers and things like that. So we make do our own way. And part of this is kind of viewed as an add-on for our clusters. And then the final thing that declares a maintainer is really important. Something that we believe a lot in is that all software should have someone to talk to if it breaks. Usually the someone shouldn't be a someone, but it should be some people, like a team. And so we make sure you can declare or every application must declare a maintainer before it can actually get deployed. So to take a little look at what the manifest looks like. So this is probably the simplest example of Hello KubeCon. You can see a lot of the same things you would expect to see in a pod spec or a deployment or a replica controller. There's containers, there's named containers, there's image tag, etc. Little detail is the maintainer. Really, that's all that's different at this point. So in practice, what does this look like on Kubernetes resources? So at this point, the only thing doc creates is the deployment. And then after that, we let the controller manager take over and create replica sets and pods and everything else. But at this point, like, your application is deployed after you run doc deploy and give it that manifest. So if we wanted to build on that, and we say we want to expose a port. So now our new application has an API that we want to make sure is available to everyone else inside the cluster. You would then specify ports, ports 3000 in this case, and we would create a service object. And the service object is opinionated on how it gets named. It's named after your application. And then, of course, at that point, the API and whatnot takes over, and you have endpoints, and endpoints point to pods. And so all of these relationships are managed by doc itself. It manages the labeling and annotations that are important to making all of these things work. This is something that our users don't have to know anything about. Like, they know because we do try and share details, but ultimately they don't need to know it to do their day-to-day work, which is, I think, it's important here. And so building on this one more time, we mentioned ingresses. So since we don't have our supported public load balancers, we have this idea of ingressing into our clusters. And so again, ports 3000, define me an ingress. I want to talk to that ingress at hello-kubecon, or I'm going to name it hello-kubecon. It's going to be type HTTP, since it's kind of important to tell your load balancer what you're doing. And then you actually specify what container port you want to send it to. And so this is really important because actually at this point, if we had not said our container has port 3000, doc would have said, like, no, you can't deploy this application. This is a much friendlier feedback cycle in that you immediately know, like, oh, whoops, I'm missing a port. And the error message is usually pretty friendly, not always. Sometimes it bleeds up from Kubernetes itself, but in general, it's a lot friendlier than the manifest like kubectl create. Like, when you don't know if anyone's like fought against when that's like spitting out errors. You're just like, what is going on right now? So anyhow, and then if we look at what this ultimately does under the hood, we create an ingress object, name it hello kubecon, and then at that point, our ingress load balancers, which we manage, can look at that object and reconfigure themselves. So a couple of you might be asking, like, why do this? Why not just like expose kubectl create and let people use that tool? There's tons of documentation on it. Ultimately, we really wanted to target that 99% case, and the majority of applications that are deploying. As we break apart a lot of the monoliths that make up DigitalOcean, we wanted to make it very easy for you to spin up your stateless APIs, and then feel free to talk to your stateful databases, but otherwise, like run your API on us, and let's make that as easy as possible so you can ship that early and then continually iterate on it. Kubernetes is also a moving target. I mean, the talk yesterday where they mentioned like 5,000 commits in the 1.4, like it's an insane amount of work that goes into it. It's really tough to keep up with, which means like we didn't want to put that burden on the engineers using Kubernetes ultimately. We were okay managing that burden on ourselves since we're pretty familiar with the technology and are willing to keep up with that cycle. But ultimately, we didn't want to make that something all of our users had to know about. And so on top of that, all the best practices and also are continuously evolving. When to use deployments or replica controllers or replica sets, et cetera. And those are just things that ultimately at the end of the day, like were not valuable for most of our engineers. Instead, it was just a matter of finding the best practice, adopting it, and sticking with it when you can. And then, of course, like I mentioned, Kubernetes has all the features and all the knobs for all those features, and it can get a little overwhelming. The docs aren't fantastic; they're definitely improving, but it's just a lot to maintain, and so we didn't want to expose that necessarily. So ultimately, we decided that a smaller feature set and a simplified user experience was going to lead to better early adopters, more early adopters. And that was really important because at DigitalOcean, we weren't just adopting Kubernetes. We were also really adopting, we're adopting containers at the time. We're adopting this idea of kind of a cloud native application, this way to architect and build applications, scale applications. Obviously, as a cloud provider, we're very sensitive to that, but there's still, you still have those bad habits. And so when we say like we're adopting Kubernetes, it means we're adopting a lot more than just that ultimately. So as an application developer, like why would you deal with all these limitations and like my crazy, like you should use this? So ultimately, we also get to pitch a lot of features to our users that they otherwise could use, but they may have to manage themselves or at least configure themselves. So like out of the box, you get support for centralized logging, metrics collection, load balancing, health checking, and a couple more. And so out of this list, really only one of them is offered by Kubernetes itself, and that's health checking. Load balancing is offered if you're on a supported public cloud, but since I said we don't have that, we also are, we're essentially selling it as a feature of our clusters as well. So that makes it a little bit easier when people are like, why would I use you? And we can say, oh, all these things, all these sweet things. And so kind of to build on that example, centralized logging is we already have a great solution at DigitalOcean that another team manages that applications already talk to. So we really just wanted to reuse that. We didn't want to reinvent it using like Fluentd or anything along those lines. We just wanted to reuse what we had. And so to do so, not to go too far into details, but we actually wanted to continue writing to the syslog socket for the host machine that every container is running on. And so to manage that mounting in the socket, finding where to write it, or write to it, like finding the path to it, etc., it was just a lot easier to centralize that logic in Doc than to have like some copy-paste block that you would put in every single deployment that you would ever want to do that to. And so now that's just a feature of Doc. Is part of its like extension is it will mount in that socket or at least configure it to be mounted in, so that Kubernetes ultimately mounts it in. This has made it a lot easier to have like one less thing that changed. Big risk of adopting any new software is everything that changes is just a potential thing to break. And so we didn't want to really change how we manage centralized logging. Instead, we just wanted to show like, hey, we can still use what's there, which is important. Like we want to fit in with the existing ecosystem. And so Doc, this abstraction made it a lot easier to do that instead of sharing just snippets of code. So it's, engineers love features, operations love consistency. So when I say engineers and operations, I want to think about it more as like the mindset, not necessarily the individuals. A lot of our engineers are very operational focused. I would consider myself a software engineer, but I really love operations. But the engineer side of me really enjoys when there's that new feature I can take advantage of. But the operations side of me really enjoys when that feature is consistent with everyone else that uses it. So essentially, we may all use centralized logging, But if we don't use it the same way, then is it as valuable? So to kind of get all these sweet features, what do you need to do? Or what do I need to do as an engineer at DigitalOcean? So the big thing is really need to fit into our box. Our doc applications have some predefined requirements, some expectations that you're going to have to fall in line with. If that doesn't work, then that's a problem, but it makes it easier to ultimately build doc and then maintain the applications in production. And so what does our box look like? Of course, it must be in a container. It's a pretty big given, but at the time, that wasn't something we did a lot of. Your application should be horizontally scalable and also should be safe to run concurrently. And so meaning you may say scale 1, but we may spin up 2 at some point, or there may be 3. And ideally, it'll eventually be 1, but there's that possibility of having multiple. And so if that's going to be a problem, then you need to manage locking at an application level or something. Your application should be stateless. It's pretty straightforward. And then crash only-ish. I mean, this is a big focus on software in general, but it's exposed a little bit more on the Kubernetes and clustered software level. So like kubelets can die, schedulers get a little crazy sometimes, and then like I may just get bored and want to go like kill a machine or two. And so ultimately that shouldn't be a problem for your application. It's really a feature of building software that way. So there's always going to be snowflakes no matter what you work on, and ultimately I think it's important to not build only for them, but to optimize for the 99% case. And it seems like a pretty obvious sentiment, but I really feel like when we're deploying software, we try to fit every single use case we can, and ultimately that's just, it may be valuable for like in conceptually, but I don't think it's practically valuable for a company trying to grow and acquire new business. So to give an idea of what this looks like in practice, we had an internal hackathon a couple weeks ago. This was covered from teams across the country, or teams across the company, which is also technically across the country at this point. This is a 2-day event, really about 36 hours. Over half the company participated in it. And so on the doc side of things, it resulted in 154 doc deploys for applications that otherwise weren't doc applications before. There were 16 new applications deployed. And these are teams that weren't just engineering. This is mixed teams from all across the business. And these are also teams that had never used doc to begin with. And so it was pretty, like, it felt really good as an engineer to have that like confidence in using this new software for ultimately something that's like just going to sit around for a few minutes, and then they're going to demo. And so all these teams really demoed on top of our platform, which is really cool to see. So to get into a little bit of how it works, which is probably more relevant to a lot of people in this room, is so Doc builds on top of Kubernetes best practices. We make use of deployments. We adopted deployments before they were in their current state. We adopted when they were alpha. Doc talks to Doc server, which is just a API, a JSON API, and Doc server talks to Kube API server. It's pretty simple. Doc server doesn't have any kind of like a data store. So here's a diagram of that. As you might imagine, all the blue are things running in pods. And so there you go. Doc talks to Doc server, talks to Kube API server. And then the controllers or ingresses, some of those are more than just the controllers and ingresses that come with Kubernetes, like the Kube controller manager. That's not in the blue, that's just run elsewhere. But the controllers that we have our own controllers and ingresses that kind of power Doc and that, like I said, that load balancer that we need to make use of. So kind of a cool thing about it, cool details. Doc server is deployed with Doc, just kind of bootstrapping pain, but ultimately it gave us a lot of really good feedback. It was the first application deployed at the time. It deployed itself, and then from then on, everyone's used it to deploy. It's kind of it's just a fun relationship, similar to how you might run your schedule on top of Kubernetes and let the default schedule it. Similar idea. So Doc server, you can kind of think of it as a split between an API server and a controller. It has a little bit more logic than the API server might, but it doesn't really keep any state around. But it does act a lot like the daemon set controller maybe, or a deployment controller where it kind of marks the things it owns. And so that way we can keep track of what Doc deployed and what we've deployed as admins to kind of keep a nice separation. And then it also uses best practices. So uses labels for grouping, which is really nice. You can go kubectl git and then pod service ingress whatever and doc app equals, and you can find all of the pieces that make up a Doc app, which is pretty nice for when debugging issues that might go wrong. And it also means like anything it deploys looks a lot like anything I would deploy as an admin. So really, you can't tell it's a machine doing it, other than it does it a lot better than I do it. It ultimately doesn't look any different if I just gave you access to kubectl and you were like looking around. And then, like I said, easier integration. Doc Server provided us a chance with easier integration on our unsupported cloud. So like I said, API load balancers are a really big thing that you need, and to ingress into the clusters, and Doc Server made it a lot easier to be consistent about how we configure those things. So kind of building on that, Doc Server was kind of this idea of code, not convention. And so a lot of what I feel like the kind of sharing deployments and copy pasting YAML files is really that idea of you're sharing this idea like this is how you should do it. In reality, we know how we should do it, and instead we should write that into our tooling, at least when you do know. So we debate some of our expectations, as in how to configure ingresses, or how to configure centralized logging, or how to like configure your application itself. And then it's just a lot more consistent. I mean, it's hard for the API to do it wrong. It's very easy for a human to decide they don't like doing it that way. And so when giving them that choice, obviously it's great to give people choices, but just know that they may not always make the choice you expect. And so that's like, if you want them to make the choice you expect, then you shouldn't have given them the choice in the first place. That's how that works. And so ultimately, this is our idea of sharing patterns. And so you share patterns with the code that we write as opposed to copy pasting. So this, I always hate when talks are just all happy, happy-go-lucky. So ultimately, it's not all rainbows. Things go wrong. So DocWatch is an application that I wrote one day because we noticed there were a lot of stale pods sitting around. So DocWatch informs us when Doc has failed to do its job. And so as you can see, a teammate of mine is complaining about how noisy DocWatch can be. So part of the reason why this happens, though, is ultimately, I don't know if everyone knows this, but kubectl cheats. It has a lot of feature disparity from the CLI itself and the API. This is like not really a known problem, but a lot of things that they're thinking about will be introduced to kubectl first, and then move to the API server. And it's just really tough to kind of keep that separation in mind when you're writing code. So to kind of reference that last slide, kubectl delete or destroy or whatever, the cascading feature of that is not a feature of the API. It's a feature of kubectl itself. And so in order to delete a Doc application, we want to cascade all of these things away. But now we have to re-implement how kubectl does the cascade. It's kind of a bit of a pain. But ultimately, a lot of things are getting moved server-side, so it becomes less of a pain every day. It's one of those things to keep in mind if you ever want to go down this path of building on top of the API. Is just keep in mind it's not exactly what kubectl exposes. And kubectl really is kind of a tool on top of that. We also struggle a lot with how are we going to keep it simple. So like ultimately, we have to figure out what features are important. Like what is it important that you can do kubectl logs and tail your logs? Is it important to exec into your container? And then ultimately at that point, like at what point is it more like, is it just simpler to give people kubectl and let them use the standard tooling and like that idea of like abstraction becoming too complex at that point? So I don't know. I don't always have the answer for this, but it's just something that we do struggle with and ask ourselves every day. And I think ultimately what we'll come to is as people onboard more into Doc itself, they get more familiar with its core principles. It'll be easier to onboard them into a little bit more complex tooling like the kubectl stuff. So I think of it as a nice like marriage between the two. So kind of the big idea for all of this is ultimately we wanted to reduce developer decision fatigue so that they can make the decisions that really matter. I mean, how you run your software is part of your business, but ultimately is probably not what you get paid money for. And so any decision that goes into that that isn't like being spent on iterating and building on your core product is ultimately like money that you're probably losing out on. And so anytime that we can simplify something, make it a little bit easier so that someone else doesn't have to think about it, I think it's a big win overall for the rest of the company. Cool. And that was it. Cool. So we have a couple minutes for questions. I think he's going to ask you to grab the mic.
Yeah, I have a stick mic back here. You wouldn't mind.
So you got questions?
Thanks for the talk. Does the doc tool support multiple tenants? In other words, is the Kubernetes cluster shared between multiple users, and do you use namespaces or something like that?
Yeah, so we don't make heavy use of namespaces at this point, just because we don't. The biggest user of the Kubernetes cluster is Doc, but there is an assumption that there could be other users. We're not assuming that the cluster is only used for Doc. So it doesn't have built-in support for namespaces, but it does use its own namespace. And so it is as well behaved as it can be. It also supports a lot of things I didn't demo in terms of the manifest, but it supports a lot of the idea of resource requests and limits in order to be a better neighbor for everything else running there. So yeah, no assumption that it is the only thing running. It just happens to be the only thing running right now.
Okay.
Does that make sense?
Yep.
It doesn't seem like there's any plan, or there doesn't seem like there's any usage of multi-cluster or distributing the application. Is that something that you're thinking about?
Yeah, so when we originally started writing Doc, this is a long time ago, and so Federation was very new at that point. So even at that point, Kubernetes didn't have a great story around that idea. So we do have a support for multiple contexts, and so it looks very much like the Kubernetes kubectl, like use context A, use context B. So it's a similar idea, it's just not a great abstraction. And so at this point, it is a very manual, like I'm going to deploy this to 3 different clusters. So I didn't mention how we run it, but ultimately we have one Kubernetes cluster, at least one per data center that we have at this point. And so you might want to deploy, we actually run a lot of the data center control plane, or at least are moving more of it to Doc applications. And so yeah, that's a deploy to every data center, and so ultimately it's very manual. It's just like a bash for loop or something along those lines. But that is on the roadmap for the next thing to tackle. And so hopefully we can tackle it by just making use of the Kubernetes bits, but we don't know. We haven't really had a chance to look into Federation, but I'd love to be able to just use that and build the abstraction on top of that.
So you build for the 99% use case. What happens when you get the 1%?
Yeah, that's a good one. So we do get the 1%. My team actually is kind of also the 1%. We run a few stateful things on top of our Kubernetes clusters just to make the cluster management easier. And really at that point, the teams that are willing to kind of go down that 1% path are also teams that we feel like we can work with more directly and maybe expose kubectl to them, or build in their use case if it's not too crazy. So yeah, really it's just a case-by-case basis at that point. We also, like I said, we still have Chef. We still have we have a few other ways to deploy applications at DigitalOcean. This is not the only one. This is just the kind of focusing on the 99%. So if you need to go past that, it may be up to you. We may be able to help you. It's case by case.
Did you have any developers feel like you were getting in their way by putting an abstraction layer in front of kubectl?
Yeah, so almost none of our developers had a chance to really mess with Kubernetes before. And so some of them had on their free time, but we didn't really sell it as we're going to deploy Kubernetes and put an abstraction in front of it. We just said, we're going to give you this, try this out. So I think that's helped a little bit, so they may not know all the features that are there. And so kind of tricked them a little bit. But every day that goes by, they learn more and more, and so it becomes a little bit tougher. So yeah, it's kind of a little bit of butting heads, but I think really where that comes into play is we get a really good feedback when they do discover oh, I really need X, and so now we kind of build that into Doc, or we say, okay, maybe it's a more advanced use case, we can hook you up with kubectl and you can do it that way. So it hasn't been too big of a problem yet. I'm sure it will be as things grow and as we get more 1% use cases, but ultimately people have been pretty happy with it, so which is pretty nice.
So you mentioned scaling a little bit, but how do users get to scale their application horizontally? Do you assign a horizontal pod autoscaler to it, or do they have to go in and tweak and turn a knob when they know they're going to get a spike or something?
Yep.
Yeah.
So the current doc version, you just have a knob, and there's a scale component, and you would say I need to scale this to 5. We do support gathering metrics, so it wouldn't be a far reach to also expose some horizontal auto scaling. For most of our applications, though, we don't get huge surges of traffic similar to a shop where you might get a ton of traffic that day. It's a pretty consistent amount of traffic every day, so we don't have that kind of big burst. So it becomes less of a problem. But yeah, that's something we definitely talked about. It's been a feature that's pretty much been requested since the beginning. So I'm sure it'll come. It's just a matter of picking the things that matter the most that day.
Yeah. Thanks for sharing, first of all. Do you think there's room for the community to invest in similar tools to help others with these types of problems?
Yeah, so I do. I think there are also some initiatives for that. I mean, there are some similar platforms for deploying on top of Kubernetes. I think ultimately a lot of those platforms make a lot of decisions for the developers, and the problem is like we may not fit into that same box. And so I think that's where it becomes really tough. I think where a lot of investment could go into is the standard tooling for building those platforms. Like ultimately Doc itself is not a ton of code. It's not very complex. It's just a lot of familiarity with the Kube API using, at the time we wrote our own Kube API client because the one in the library was not great. And so since then, like, they broke that out. I think that was a big step for making it easier to build a platform, is now you have this like standard API client, for at least for Go. I don't know about other languages. Those don't really exist, but it's fine.
Thanks.
Cool. Anything else? Okay.
How do teams run their stuff locally?
Yeah, that's a good question. A lot of teams use just Docker composes. So we don't expose any kind of like run your own Kubernetes locally. It is possible to spin up like a local kube stuff and build Doc on top of it. It's not a crazy abstraction such that you couldn't do that. It's just really complex. And so Docker composes fit that case for the most part. And then building on top of that, like we do offer, there are development and staging clusters of Doc. So you can deploy your application from minute one to that cluster and mess around with it. And have it be completely isolated from the rest of our production clusters. Like it's a separate physical Kubernetes cluster as opposed to like a logical namespace or something like that. And so it gives it a little bit more confidence for just pushing things as needed. But yeah, the local dev story is something that's kind of growing, and Docker Compose has filled a lot of that niche so far.
Hey, what is one thing you wish we had not built into Doc?
Oh boy. So this is one of my teammates who knows. I think one of the things that we missed our target on a little bit, maybe not something we shouldn't have built in, but is how you introspect your application. And so there's a lot of resources that Kubernetes exposes with logs, with events, with just the overall like showing, inspecting, getting the YAML itself, and all of the state that's contained therein. And I think our abstraction on top of that just wasn't the right abstraction. So I think that's probably one of the tougher things to build if you ever think about building an abstraction on top of Kubernetes, is how do you introspect that the thing is working, that it will continue to work, and like what it did over the last 5 minutes or something. I think that's probably the thing we can improve the most. And I think it's also where something like a standard library for building platforms like this would go a long way, because it would give that consistent view of like what the world looks like. Cool. All right. Well, thank you. I'll be here. Feel free to.